Hey, Mr. H coming at you. This looks like now it's back to being Thursday's assignment since you're all out on cold break today, well-deserved cold break. So as you get started here on this, I know it says Chapter 8 and we're in Unit 4, but just work with me on it here. It covers the same things. And welcome to my home basement office, if you want to call it that. Hopefully I won't have to use this anymore this year. We'll see how this goes. I wanted the opportunity to go through a few problems on this worksheet with you since I'm not there live to be able to answer questions. The review is up for the Unit 4 test. I'm still thinking we're going to be on schedule to hammer through all the questions that we may have on Monday and be looking at Tuesday, Wednesday, but as always, that's subject to change, so I'll keep you in the loop as I know. And one last thing, as I'm almost a minute in here and we haven't done any math yet, I do appreciate those of you who have reached out with your concerns and your well wishes. I and my family appreciate that very much. Okay, let's get down to business. So reminders here as we start to look here towards the end of this unit. And if you didn't see before, I've eliminated some questions from the review and some things you won't have to worry about in the test. The video lesson I originally had set up for Wednesday, 8/8, we're not doing for many different reasons, including me not being there to answer questions. So if you have more questions on that, let me know. All right, let's sketch a graph here. I'm going to do some odds just to kind of get you rolling back into the theme of things here. So when we're sketching these, there's a couple things we can do. I'm actually going to use my, if I can find it, there it is. I'm going to use my Calculate 84 here because smart teacher, I don't have a graphing calculator here at home that's functional, so good job me. So when I go to get some help with this and put it in the calculator, if there's anything with a fraction, it needs to be put into parentheses, unless you're going to go decimal form on me. And I'm going to try to do my best to stay out of the glare as best I can, but no promises here. So I get that in. I have a pretty good idea of what this is going to look like. But what I'm trying to do here is, you're always hoping that you're going to get, whole numbers when you come to the chart. Well, that's not always going to happen. And so what we're going to have to do at times is kind of make the best of some things. So we're a little above, and then I notice there's no up or down shift. So I know my asymptote is going to be down here. So I know its end behavior is going to go this way. But I still want to get a few values in so I can make that. Did I just do that the opposite? Oh, Hardy. Problem number one, and I'm already having problems. Is that just like the way this is working or what? So you don't see this. You don't see that at all. Because you're like, Hardy, it's growth. Why would it go down that way? You know what? That's a true statement. So let's get that situated the right way again. We don't see this. That's not there. And we're just sketching the graph. We're not doing the end behavior. We're not doing domain and range here, even though domain and range wouldn't be hard. On growth and decay, if we were doing domain and range, oh, Hardy's going to do it now anyway. On growth and decay functions, the domain is infinite. Remember, on logs, those flip. And my range, unless there's an up or a down shift, which there's not, is always going to run from 0 to infinity. Okay? With the rest of these, okay, solving the equation, you need the same base. I need 16 and 64 to have the same base. I can't take 16 to some power and get 64. So now I got to get creative. I got to go to a base that's smaller. What's another way I can get to 16 with an exponent? 4. So I'm like, okay, well, that'd be 4 squared. And then if I'm going to use 4 over here, I got to use it over here as well. So 4 to what power is 64? That's 3. And we've spoken before about how because of logarithms, those are going to go away and just leave me 2 times negative 3k, divide both sides by negative 6. And we're in business. okay? So sometimes you might have to change one, sometimes you may have to change both. But in this case, that's what that's going to be. And then the part that almost caused the most problems in the last quiz, and no, I have not lost them, I have not thrown them away. If you've been reading my stuff, I just have had a couple things going. So I am working on those. They are a work in progress. I will have those completely in the gradebook here soon. And then all the retakes and stuff, if you want to, we'll just push back a week. Rewrite an exponential form. Basically, it's saying, hey, make them look like number 7 and number 8. So when we do that, this is always my base. This is always my exponent. This is always my answer. Okay? Base, exponent, answer. If you really want to be funny, look, it's your bay. Ha 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 ha. Okay, terrible old guy joke, I know. But if you're looking at what order they're in, that's the order they're in. Okay, and if I punch this into my calculator, 125 to the 2/3 is 25. So, just something to look at. When we're going to log form, we're trying to turn these back into these. So, log, my base, my big number here is always here. The exponent, always over here. The answer, always right here. BAE, okay? Once you've got it locked in one direction, you should be able to kind of just manipulate it through. And again, you could even check this. Change a base. Log 4 divided by log 2. Punch that in your calculator, you're going to get 2. And you know you have the right answer. Something to look at. Okay. Expanding, stretching your logarithms. And as we said before, the only exception to starting with your multiplying or your dividing here on these is if you have an exponent out here, okay? And there's multiple things going on in here. I would take care of that first. So this would be log base 9 u to the 36th, v to the 6th. Now I can look and go, ooh, multiply as add. Log 9 36 plus log 9 v6. Okay, division, multiplication always are going to come before we deal with the exponents, because otherwise if we do the exponents first, then we think there's a lot more there to expand. So if we get those come at the end. Refer back to your notes on expansion and condensing if you have forgotten. And once we've gone through all the three possibilities, multiply, divide, let me put it in the right order, divide, multiply, exponents, you're good. And we'll do number 11 as well because there's a funky little twist in here. Even though once we take care of it, it's not going to look too funky. We look at 11 and you're like, ew, what's going on there? How can I make the square root an exponent? I get 1/2. Otherwise, this is going to look eerily similar to number 9. When you get to the multiplication dot, it becomes plus, and we start a new log. If there are exponents, they are going to become coefficients. At the end, you should see no more division, no more multiplication, no more exponents, if you've done your expansion correctly. So just kind of walk through that a bit. But again, if you have exponents outside of something before you start, get that taken care of first. Okay, get it into a format like this, then go ahead and start working from there. Okay, condensing, we're just undoing all that stuff. We're smashing it back down into one logarithm. Now, 13 looks kind of funky. Like, what's going on with that? Like, are we supposed to be putting things into divide? So let's rewrite this one. I'm going to do it up here above, and then we'll come back down. Dividing by 3 is the same as multiplying by 1/3, and the same on this one. So with that in mind, when we condense, remember we're doing it in the opposite order that we did it before. So before the exponents were last, now the coefficients are going to be first. So we'll get those up here. So we got log 5z plus log 5x to the 1/3 plus log 5y to the 1/3. Now, we don't have any division because that was basically just our exponent here. So add becomes multiply, and we want to smash this together into one logarithm. So log 5z times, you don't have to put the multiplication dot in because we assume it, but I'm just doing it for visual effect here. X to the 1/3 times y to the 1/3. One logarithm. Okay? And whether you're doing condensing or expanding with logs or natural logs, the rules do not change. Nothing's going to be different. So here, I have coefficients. They're going to become exponents. Those are going to be really, really big values. So it's fine if you just leave them as exponents like that instead of trying to get the crazy numbers. And then the only thing left is this subtraction, which is divide, divided by one log, or one natural log in this case. Okay? So we kind of keep going with this. Solve the equation. Round your answers to the nearest 10,000th. Okay? Here on 17, you've got to get your term with the variable alone before you start trying to undo it. Like here, I can't use natural log right away to get rid of e. That 9's in the way, so I got to divide by 9 first. So let's see here. 91.6 divided by 9. Nearest 10,000th. Okay, so divide by 9. So we've got e to the k minus 7 equals 10.1778 tenths, hundreds, thousands, 10,000ths, 4 decimal places. How do I get rid of e? Its enemy is natural log. So I'm going to take the natural log, and again, if you're on your calculator, right below log there, okay? Even if you're just using the regular calculator on your Android or your iPhone, if you turn it, maybe you haven't done this before, I don't know. If you turn it, maybe, if it's going to be nice, there we go. You're still going to have, you have natural log and all that stuff on here. You even have e on there. You don't even have to do a second if you just turn it sideways. I believe that's the same on the Android phone. I'd have to go ask my wife to borrow hers, which I'm not going to do currently. But it does give you that extra option if you haven't dealt with one of these. So, go ahead, we'll get that in here. So we got k minus 7 equals approximately 2.3202. And then just add the 7. You're like, dang, this is getting a little ridiculous. This is called upper level math, ladies and gentlemen. It's not that they're really hard things to do. We're just not used to dealing with stuff that's quite this decimally. So, you know, and number 19 is that's just kind of beastly. So I'm going to do, for lack of space here, I'm going to do most of 19 on the calculator and show you. Most of the time, if you see stuff smashed like this, you're probably going to want to go ahead and get it out onto a piece of paper, because I do that a lot myself. So my first job is going to be to get this alone. So I got 2 steps that I need to do before I get there. My first step is going to be to add this 6.2 out of there. So let's do that first. Okay, that's 84.1. Then I need to divide by the 7.2 that I'm multiplying by. So here's where I'm at right now. So 6 to the x plus 2.6 equals 11.6806 if I round, after I do my adding and my dividing. Now, you cannot just divide by 6 here. I know you want to. I'd want to as well. But that exponent is up there, so what is our new other inverse friend besides e and natural log is a log in its base. So that would get us just down to the x plus 2.6 on this side. Over here, we're going to do change of base. So remember, when we do change of base, it's going to be log big, which in this case is the 11.6806. Oops. Oh, for the love. Oh, let's just start over. Technology is great until it just starts going crazy on you. Well, let's be honest, that was a user malfunction. Okay, so there we go. Divided by log 6. Log big divided by log little. 1.3718, because that's going to round up. And subtract the 2.6. X equals negative 1.2282. Now, yes, our feelers go up when we get the negative answers. However, okay, a couple things here. However, notice in our original problem there are no logarithms. Okay, that's the first thing we don't need to put the feelers up for. And secondly, even if we had this in there, that's going to be a positive exponent, so it wouldn't matter, even if it was a logarithm. But good job for thinking if you were thinking that way. Okay, solving for the equation, I don't need to do a ton of these because we don't need to repeat over and over. If you have a log of the same base on both sides, you're basically just turning this into set the two sides equal. And add your 5p over and subtract your 8 back. Now be careful. Are we going to be okay with this? Or is this going to be one where my answer doesn't work and I get no solution? And I'm just checking my work again to make sure I didn't do anything crazy. Nope, I didn't. Negative times negative is positive. So positive 75 minus 7, that's fine. Over here, negative times negative is positive. 8 plus 60 is also fine. So that one's fine. Again, feelers up, yes. But is it always going to be that that doesn't work? No. Okay. And the only other thing we really can run into here is something like number 25. If there's two logs on one side, we need to do some condensing first. Okay, we can't just do 5, 5, 5. You're like, well, why not? Okay. Well, what you're doing now is you're exponentiating twice to this side and only once to this side. In algebra, we know we want balance. So 2 on this side, 1 on this side is not balance. So to get that balance, minus is going to become divide. Oops, I lost my log. And now that there's only one log on each side, and those two logs have the same base, 5, now, by rule, we can exponentiate and now get into something that is much more manageable. Get that fraction out of there first. And get to your answer. So other than that, when you're solving, as long as there's one log on a side, you're good. Or if there's a log only on one side, and it's just a number on the other side, sort of like what you would be looking at for number 26. Condense it, but then once you condense it, still do your exponentiating. But the difference here is going to be on this side, the exponentiate is just going to cancel the log. On this side, there's nothing to cancel, so you actually have to multiply that out and then divide by 24. So, details. But again, how do we take care of details? We practice enough that those details don't get us when it matters the most. Okay. Is this the end? I think this is the end. Yeah, that's the review, and the review video is already up. All right, this is the last one I'm doing. identify the domain and range, sketch the graph. And you don't have to do it in that order, of course. So logarithms, this is going to be a little different. We should be able to do our domain and range before we ever start here. Our range, when we're doing logarithms, is always infinite. Growth and decay, it's domain. Okay? So the first problems we did on this worksheet, definitely the opposite of what we're doing here. And then my domain only is going to change from 0 if there's a left or a right shift. Probably pays, even though they didn't ask me, to go ahead and jot down what those shifts are just to remind me. So I'm like, okay, so I'm going right 3 and down 2. Right 3 means my domain is moving right 3, and that my vertical asymptote is moving right 3. Then for your points, again, we've chatted about this. You can punch that directly into the calculator and just take points. I'll even pop that up here in a second. Or you can remind yourself, there are my 2 base points, but they're each being shifted right 3, which means I'm adding 3 to x, and down 2, which means I'm taking 2 away from y. And just plot those 2 points. Now again, I know 13, -1 is like completely into the next problem. I hear you, I understand. Oops, I didn't want to get rid of that. Log x minus 3, close them. Make sure to close them, -2. If I look at my chart, remember the error messages are saying, hey, anything to the left of that last error is a problem. 3 is the error, 3 is the asymptote, okay? And then check it out, 4, -2, oh, drum roll, 13, -1, that's right. Thank you very much. Thank you very much. -2, 13, -1, it's like way out here somewhere. When you graph these, they keep going and hug the asymptote. I don't care if your calculator looks like it stops. That is not what is going on. It is that the asymptote is blending right in with it and you can't see it. So do not stop your graph right here unless you want to get something taken away. Okay? So again, your goal for the rest of this week, since hopefully you're just staying warm on Wednesday and looking at this Thursday, work on the evens for this on Thursday. Start working on the unit review. Check some of the review out Friday, maybe a little Saturday or